Have you ever wondered, in this vast universe, are we alone? Could there be other planets like ours orbiting stars far beyond our reach? The answer, quite simply, is yes. These planets, known as exoplanets, exist beyond our solar system, orbiting other stars in the cosmos. Exoplanets open up an entirely new realm of scientific exploration, a frontier where we can search for signs of life beyond Earth, for planets that may resemble our own. These celestial bodies are scattered across the vast expanses of the universe, each with its unique characteristics and mysteries. Since the first exoplanet discovery in the early 90s, our knowledge of these distant worlds has grown exponentially. We've located thousands of these celestial bodies, and with every new technology, every new telescope that scans the cosmos, we find more and more. It's estimated that there could be billions of exoplanets in our galaxy alone, a staggering thought that humbles us and highlights our minuscule presence in the grand scheme of the universe. Exoplanets come in all shapes and sizes, from gas giants larger than Jupiter to rocky worlds smaller than Earth. Some are scorching hot, with surfaces that could melt lead, while others are icy cold, with oceans that could be frozen solid. They orbit stars that are different from our sun, stars that are bigger, smaller, hotter, cooler, younger, or older. Some exoplanets exist in the habitable zone, a region around a star where conditions might be just right for liquid water, a key ingredient for life as we know it. These planets, known as Goldilocks planets, are of particular interest to scientists, offering the tantalizing possibility of extraterrestrial life. But how do we find these distant worlds in the first place? How do we spot a tiny, dim planet billions of miles away, orbiting a bright, distant star? The answer lies in the ingenious methods employed by astronomers, a blend of technology, mathematics, and sheer determination. So we know they exist. But how do we find these distant worlds in the first place? Finding an exoplanet is like trying to spot a firefly next to a bright lighthouse from miles away. It sounds impossible, doesn't it? Yet, astronomers have risen to this challenge, using ingenious methods to detect these distant worlds. Firstly, there's the transit method, which is a bit like playing cosmic hide-and-seek. When an exoplanet passes or transits in front of its host star, it causes a slight but detectable dip in the star's brightness. This tiny flicker, often less than 1% of the star's light, is the telltale sign of an exoplanet. This method requires a careful eye and even more careful calculations, as astronomers must distinguish between the star's natural variability and the dimming caused by a transiting exoplanet. Then there's the radial velocity method, which leverages the gravitational tug-of-war between a star and its planets. As the exoplanet orbits around its star, it causes the star to wobble ever so slightly. This wobble changes the color of the star's light, shifting it towards the red end of the spectrum as the star moves away from us, and towards the blue as it moves closer. This shift, known as a Doppler shift, can be measured precisely, indicating the presence of an exoplanet. But the art of exoplanet discovery extends beyond these methods. It's about patience, as confirming the presence of an exoplanet often requires multiple observations over several years. It's about precision, as even the tiniest error can lead to false positives. And above all, it's about perseverance, because despite the odds, astronomers continue their quest to find these elusive worlds. Through these methods, and the dedication of countless astronomers, we've discovered a diverse array of exoplanets. From gas giants larger than Jupiter to rocky worlds smaller than Earth, from planets with molten surfaces to those with potential for liquid water, each discovery paints a vibrant picture of the universe beyond our solar system. These methods have revealed a diverse array of exoplanets, each more fascinating than the last. Imagine worlds where it rains diamonds, or where a year lasts just a few days. Welcome to the Exoplanetary Zoo. The diversity of exoplanets discovered so far is nothing short of astonishing. These alien worlds range from gas giants reminiscent of our own Jupiter and Saturn to smaller, rocky planets similar to Earth and Mars. But the Exoplanetary Zoo doesn't stop there. There are super-Earths, planets up to 10 times the mass of our own, and mini-Neptunes, with a mass somewhere between Earth and Neptune. Some of these bear striking similarities to our own world, while others are as different as can be. They orbit their stars in ways we once thought impossible, and exist in conditions that defy our understanding of what a planet can be. Take, for example, the hot Jupiters. These gas giants orbit their stars so closely they experience scorching temperatures, leading to a year that lasts just a few days. Then there are the ice giants, where the pressure is so high that it literally rains diamonds. But it's not just about the extreme. There are also Goldilocks planets, worlds that fall within the habitable zone of their stars, where conditions might be just right for liquid water to exist. These are the planets that really get scientists excited, as they offer the best chance of finding life as we know it. We've also encountered pulsar planets, orbiting the remains of exploded stars, and rogue planets, drifting through the cosmos without a star to call home. Each new discovery adds another creature to our exoplanetary menagerie. These diverse worlds challenge our understanding of planet formation and evolution. They make us question what we know about our own solar system and push the boundaries of our search for life. So while we may not be able to visit these distant worlds just yet, studying them from afar provides invaluable insights into the universe we inhabit. These diverse worlds open up tantalizing possibilities in our quest to find life beyond Earth. Is there life out there? Exoplanets may hold the answer. The quest to find life beyond our home planet revolves around the concept of the habitable zone, often referred to as the Goldilocks Zone. This is the sweet spot around a star where the temperature is just right, not too hot, not too cold, allowing for liquid water to exist on the surface of a planet. It's this precious liquid that is considered key to life as we know it. Yet, being in the habitable zone is only part of the story. A planet needs to have the right size and composition too. If it's too small, it might not be able to hold an atmosphere. If it's too big, it might be a gas giant like Jupiter, without a solid surface where life could thrive. The study of exoplanets, therefore, is not only about finding new worlds, but also about understanding the conditions necessary for life. It's like piecing together a cosmic puzzle, where each discovery adds a piece to our understanding of the universe and its potential for life. Interestingly, there are some exoplanets that challenge our very definitions of habitability. Take the case of hot Jupiters, gas giants that orbit very close to their stars. They're unlike anything in our solar system, and yet, who's to say what strange forms of life might exist in such extreme conditions? Then there are super-Earths, rocky planets larger than our own, which could potentially harbor life. Some of these worlds, like Proxima Centauri b, are tantalizingly close to us in cosmic terms, whetting our appetite for exploration and discovery. So, can we visit these exoplanets? Well, with current technology, a trip to even the nearest exoplanet would take tens of thousands of years. But who knows what the future holds? As we continue to push the boundaries of science and technology, perhaps one day we'll find a way. While we dream of setting foot on these distant worlds, the reality is a little more challenging. But that won't stop us from looking, learning, and wondering about the vast universe we inhabit and the life it may harbor. Despite our curiosity and technological advances, exploring exoplanets is no easy task. The challenges we face are as vast as the universe itself. The most significant of these challenges? Distance. These celestial bodies exist light years away from our own solar system, making them inaccessible with our current technology. The light we see from these distant worlds left their surfaces years, even centuries, before it reaches our telescopes. Another major hurdle is the sheer size of the universe. With billions of stars in our galaxy alone, each potentially hosting a planetary system, the task of cataloging and studying each one is daunting. It's like trying to understand the depth of the ocean by studying a single drop of water. Then we have the technological limitations. Our methods for detecting exoplanets, like the transit method or radial velocity, are ingenious but not without their limitations. They require precise measurements and a lot of patience, as we wait for a planet to pass in front of its star or cause a slight wobble in its motion. But for every challenge, there's a solution in the making. Our technology is constantly evolving, and with advancements in telescopes and detection methods, we're getting better at spotting these distant worlds. Initiatives like NASA's James Webb Space Telescope, set to launch in the near future, promise to revolutionize our understanding of exoplanets. And what about the future? Well, it's as boundless as space itself. As we refine our technology and methods, we will be able to study exoplanets in more detail, perhaps even detecting signs of life. We may also develop spacecraft capable of reaching these distant worlds or even harnessing the power of light to propel us forward. As we continue to uncover the secrets of these distant worlds, who knows what wonders we'll find. So next time you gaze up at the night sky, remember, each star could be a sun to another world, just waiting to be discovered.